Hello students, welcome to another video on chapter light for class 8. Till now we have covered the basic concepts of refraction. Today I'll be explaining you about refraction of light through a parallel sided glass slab. So let us begin. In the given diagram, students, this is representation of a glass slab A, B, C, D. Now you can see a light is coming and falling on this. Obviously that's the incident ray, right? And now as it passes through the glass slab, it will bend towards. So here the value of R, that is angle of refraction, is obviously going to be lesser than the angle of incidence because it's coming from air and going into a denser medium. So air is a rarer medium and the slab is a denser medium. So the refracted ray moves closer to the normal, and as it passes and comes out from the other side, as it is moving out of the denser medium again to the rarer medium, it will move away from the normal. Now this ray is called the emergent ray. This is a new word for you because you have read about incident and refracted ray. Now this one, which is emerging out, the light ray that is coming out or emerging out after being refracted by the glass prism or the glass slab, is called the emergent ray. Okay students, so the angle which is being made by this emergent ray and the normal again is called the angle of emergence. Also, if you carefully observe that this emergent ray, if I take it back, it is going to be parallel. There is a shift, and if I just extend this incident ray, if there was no refraction, it would have been like this. So there is a parallel shift that you can see between the two rays, the incident ray and the emergent ray, and this shift is known as the lateral shift or the lateral displacement. So how do you define a lateral shift or a lateral displacement? It is a perpendicular distance between the incident ray and the emergent ray. That's called the lateral displacement or the lateral shift. Now there are some points that you need to remember, like the angle of incidence is definitely more than the angle of refraction in this case, because as I told you, it's moving from a rarer to a denser medium, so it will move closer to the normal. Also, you will see that the sin I by sin R is a constant, what we call as a refractive index. The ray of light, after passing through the glass slab, you can see it is emerging parallel to its original path, and it's suffering a lateral displacement from its path, which we called as a lateral displacement or the lateral shift. Do remember these points related to the refraction of the light through the parallel sided glass slab. Now let's talk about refraction of light through a prism. You all might have seen a prism, children. A prism is an optically transparent device made up of glass with triangular bases and rectangular sides. So this is just one 2D form I have shown you, but if you see a prism, it is having the rectangular sides, but when they join together they form a triangle, right? And the angle between the two refracting surfaces, they are called the angle of prism, which I have shown here with the letter A. Now if there is a light which is incident on this prism, it generally moves towards the base of the prism and then it emerges out. So this is an emergent ray, this is a refracted ray, this is a incident ray. The angle that it makes with the incident ray and the normal is angle of incidence. The angle that it makes with the emergent ray and the normal is the angle of emergence, taken as E here. And if I extend this incident ray and the refracted ray, this angle formed between them is known as the angle of deviation. It is that angle through which the incident ray is deviated when it passes through the prism. That's how you define it. And a very interesting relationship which you should know is the angle of incidence, that is I, and the angle of emergent both add up to the angle of prism, that is angle A, plus the angle of deviation. This is a very important derivation as such, but in class 8 you don't need the derivation. You just need to know the relationship between the different angles here. So you should know that angle of incidence I plus the emergent angle or the angle of emergence is equal to the angle of prism and the angle of deviation. Okay. Now there is a very nice phenomena which happens here, children. When you see a prism and a single white light is passing through the prism, it generally splits up into a beautiful 7-color band. Now this phenomena of the splitting of the white light into its component colors is known as dispersion. And the band of the colors which is formed is called the spectrum. Okay, that 7-color band is called spectrum. That colors are in order of Vibgorgia, that is violet, indigo blue, green, yellow, orange and red. This is the band of the 7 colors that you see. And can you guess where you have seen all these colors together in a very beautiful order? Yes, I think you have guessed it right. It's the rainbow, which we see sometimes after a rain. So what actually happens? How does this prism be able to split the white light into the 7 parts or 7 colors? It happens because the refractive index of the glass is different for different colors, and hence each color is traveling with a different speed inside the prism. So what will happen? The speed will change. One will become slow, one will become little faster than the other, and that is why the white color is seen to split into this 7 beautiful colors. Also you will see, children, that the violet light, it suffers a maximum bending. And why does that happen? It's because of the refractive index. Okay, now you know what is refractive index. It happens because of the refractive index of the glass. It is maximum for this violet color. So it suffers refraction and it bends quite a lot. And also you will see that the minimum the bending of light is happening for the red color. So we can say that violet color is suffering the maximum bending. And if I take 2 prisms, children, I'll just like to show you a rough diagram here. If I am taking 2 prisms, one is like this and one is like this. One light is going to break into 7 colors. And when it will fall on the other prism, which is kept in an opposite way, the lights are going again to fuse and come out as a single white color. If 2 prisms are kept in opposite direction, one base is down and one's base is up. So what is going to be observed? You will see that a single prism, it was breaking the white light into 7 colors, and when 2 prisms are kept in the opposite directions parallel to each other, it's forming like a glass slab. And then the dispersion is reunited in the other prism, and then the components of the spectrum of colors is becoming the white color again. So the beautiful phenomena we were talking about, that is the formation of rainbow. What is the rainbow? You all know that it is a circular arc of colors which is formed in the sky, and it is always formed opposite to the sun. Now what happens, children, when it rains, there are many droplets of water, and the sun's light passes through all of them and they break into the 7 beautiful colors, and that is why scattering of light is happening and the rainbow is being formed, because each tiny droplet is acting as a prism which is optically denser than the air around it, and thus the light ray suffers refraction. And each color inside the water droplet, it travels at different speed, thus it does not come out at the same time, and the splitting of colors is seen in the form of a spectrum which we call the rainbow. Another very important thing that you should know about is that why does the sun appear red during sunrise and sunset? You might have seen, children, obviously there is light around when the sun is there, and this light is traveling with the maximum distance from the atmosphere to reach the observer, right? And what is happening in the way? Scattering of light. So the light is losing the colors with shorter wavelength. Now you should know that shorter wavelength are obviously the violet, indigo, green, blue colors, right? And therefore the maximum traveling of the colors is done by the orange and the red color, which is reaching our eyes, and so we feel that the sun is looking red. Also, you will see that red light is used for the signaling purposes, for showing signs which need to be observed from faraway places, right? So it is used in electrical towers, radio antennas. Why? Because it is having the maximum wavelength and it scatters the least, right? And it can be spotted from a distance by the observer. So that's the reason red light is being used in many places, so that the observer can see it from a far place. It will not be scattered much. So with this, I'm very sure you have got the basic idea of the chapter light, where you have read about the refraction, what is the concept of refraction, how it happens in a glass slab, how it happens in a prism. Do tell me in the comments box, have you ever observed a prism in real life? Tell me a yes or no in the chat box. Thank you for watching.